Hello, my name is Daniel Bruce. I'm part of the Capstone 2 team working on the AmLight research project here at Florida International University. This is going to be the demo video for the showcase. So in order to do everything here, additional videos will be in our Capstone 2, the Capstone or Senior Project YouTube channel under our Capstone 2 AmLight playlist. So the first demo we're going to show you is installing the library into your system and actually utilizing it into your own project for whatever your needs may be. I'm not going to go over the installation part since this is mainly for demoing, but that video has been produced on the Senior Project YouTube channel under the Capstone 2 AmLight playlist. But we're going to need to have Network X installed onto your system and the ExactDelay Pathfinder core, which is our library for the exact path algorithm. Both of these can be installed with pip. So pip install Network X, pip install ExactDelay Pathfinder. Now, if there's future Capstone students working on the AmLight project, like in the next following semesters, there is a way to build the library manually and install it manually if they need to modify some code within the algorithm or just within the library itself in general. So that video is also in the installation maintenance guide on the Senior Project YouTube channel within our playlist. But after both of those are installed, we can start doing some code. So we're going to create a new Network X graph instance, which is just nx.graph, so g is equal to nx.graph. We are going to add some nodes to our graph, user 1, S2, S3, S4, S5, S6, and user 2. We're going to add those nodes to the graph, to the graph instance, Network X graph instance of G. Then we're going to create some edges. So with propagation delay, which is the metadata. The metadata is going to hold that propagation delay, as we can see here. So user 1 S2, delay 10, user 1 S3, delay 37, and so on and so on. So these edges are the links in the topology. And between those links that connect to hosts, switches, or interfaces, we'll have a propagation delay between them. So that's how it all works. We're going to add those edges to the Network X graph instance. And then we're going to create a new instance of our ExactDelay Pathfinder. EDPF is equal to ExactDelay Pathfinder. We're going to create an empty list. We're going to name it result, and we're going to assign result some data. And that data is going to come from the search function in our ExactDelay Pathfinder instance EDPF. So in this method signature, we have a Network X graph, the propagation delay we are specifying, and the starting node and the targeting node. So I want to find a path in our network topology between user 1 and user 2 with a delay of 179. So when we're traversing our topology, I want to see if there is a path between user 1 and user 2 which that traverse path has a delay of 179. So let's go ahead and run that, and of course we just print the result here. This is just a very brief example of utilizing our library into your own project. So we get 179, 128, 262. So depending on the scale of your topology, depending on the scale of it, our library or our algorithm is going to return up to 10 results, and that all depends again on the scale of the topology. We got 3 results this time. We got the exact path and 2 closer or potentially closer ones. This one's definitely close. This one's a little bit far. Let's bump that up to 200. As you see, we have a closer path versus 179, 217 right here. 179 is that second closest one, and then we got that 262 that's still hanging out all the way over there. If we change this to 217, we should get that exact path with, yeah, still 179 is that second closest, and 262 is a little bit still out there. So that is utilizing our library into your own project. Now we're going to demo using the Ketos UI with our beginning integrations into the Pathfinder N-app. So I'm going to show you that right now. Okay, so I switched over to my virtual machine, Ubuntu. This is where I do all my Ketos development. But before I continue, I want to briefly explain why we had to shift the focus midway through the semester for our project. Now, when we were ready to integrate our exact path algorithm into the Ketos Pathfinder N-app, when we loaded in topology through Mininet, the links between the interfaces and switches would be missing, and also the metadata would be missing, which houses the propagation delay. And we later discovered after this shift of focus in our project that it was happening in the topology N-app. And David Ramirez and Marvin Torres, they are members of the Spring 2020 senior project team, were able to create an unofficial fix or unofficial revision for the topology N-app, so we can at least begin the integrations of our exact path algorithm into the Pathfinder N-app. But since this is an unofficial fix, this is why this is just the beginning integration. This is an unofficial fix. But by the time we contacted the Ketos developers of this issue in their latest official revision of the topology N-app, and they look into it, and then they try to make a fix as fast as they can, and then push it out as fast as they can, there would have been a lot of time wasted within the sprints and the development periods. So this is why the shift of focus of our project mid-semester happened, and the main focus was to create the exact path algorithm library. So what I'm showing you right now is using the unofficial fix by David Ramirez and Marvin Torres for the topology N-app. And our exact path algorithm, not just the algorithm code, but our library integrated into the Pathfinder N-app in the Ketos UI. So let's go ahead and start our virtual environment. Now I'm going to check if Ketos was running, because I had Ketos running previously. I don't think so. It is, so I want to kill that process. There we go. Let's start Ketos. We're going to go to our browser, localhost. That was some weird ads by Mozilla Firefox there. Alright, there we go. So make sure this wasn't cached. Okay. And this map icon is the unofficial revision of the topology N-app, to where we can upload a text file that has our topology data into it. So we're going to upload the topology via text file rather than load it into Mininet. If I bring up the developers console here, click upload, we can see the operation was successful. Now we could get like a successful message here in the Ketos UI. But since this is just an unofficial fix, and this is just for testing the beginning integration of the exact path into Pathfinder, but we could go ahead and add that in as well, just to make it a little bit more user-friendly. So as you can see, our topology has been loaded, the links are there, and the metadata holding the propagation delay are also there as well. They're not missing. We can go ahead and look at information here between each of these switches. Now we're going to go to this compass icon, which is the Pathfinder N-app, with our changes or implementations for the beginning integration of the exact path algorithm library into the Pathfinder N-app. So we have a slider here, it goes all the way to 1000 ms. I don't imagine that developers are going to want to, or users would want to find a path past 1000 ms. We're gonna want to find maybe 263. And I want to find that between, let's say, A2 and 5.4. If we search for that, we can see the pan popping up on the right with up to 10 results depending on the scale of the topology. This topology is a little bit bigger than the previous one we were showing in the Visual Studio, but we get quite a number of results here. The closest path from A2 to 5.4, the switches, is 261. As we can see on here, this is the closest path. As you see, we have a list of all the switches it has traversed, A2 all the way to this 5.4, with a delay of 261. The next one is 260, and so on and so forth. The list will go on up to 10 results. So that is the demo. One last thing actually I want to show is you can also view the JSON response here as well that houses all of this data in this pan here. So that is the demo with our project for the exact path algorithm and the beginning integration of our exact path algorithm library into the Pathfinder NApp. So we look forward to showcasing this on December 4th, and thank you guys for watching.